Once upon a time, some of you have heard this story before, the only problem 20 years ago was when someone tripped over a cable, right? Now, if you look at problems, you have a rogue device showing up in your network at 3 p.m. Someone fat fingers configuration and creates a topology loop at 3 a.m., and you don't know why, what happened. Or you have a brownout occurring on a port, and your security cameras are stuck. You're not getting the video feeds that you need in your network, right? So the problem definitions have actually changed, and that brings us to the core of this session for AI-native self-driving networks. My name is Sanjoy Dey. I run the wired wireless Mist portfolio. And then with me, I have Sujit. He's the lead, a director of product marketing. He is going to be my partner in crime for the session today. So as I was kind of alluding to, when networks fail today, people don't complain that my OSPF adjacency is not working or my BGP route reflector is not functioning and I have high latency. What they talk about is, in the case of our retail partners, my checkout lines are not moving. Or if you're from higher ed, they complain that students can't access the network and they can't take their exams. Or if you're in healthcare and pharmaceuticals, you don't have access to the manufacturing assembly lines, or clinicians don't have access to charts, right? Which means that the failures are actually in the business outcomes. And that brings us to, when we talk to partners and customers such as yourself, what are the challenges that mire you? And the themes are very repetitive. It does not vary too much from customer to customer. How do I deploy fast? How do I migrate without taking a whole lot of downtime? How do I get assurance and make sure that my users are getting the experience they deserve out of a network transformation project? How do I make sure that that rogue IoT device I talked about does not show up, and if it does show up, I have a way to remediate it? But my personal favorite is, where do I have the visibility, right? If you can't see, you can't find a problem. If you can't find a problem fast enough, you basically cannot remediate the problem. So this is basically the premise for what Juniper Mist, what we have done with our switching portfolio, which we call AI native, and I explain AI native in a minute. The vision is going to a self-driving network. If you look at all of your challenges, you have basically three main vectors of challenges. One of them is cost. And it's not just the cost of switches, because the cost of switches and access points is one part of the story. You have to think of your floor space. You have to think about more power-sucking alien, high-power 802.3 BT cameras, Wi-Fi 7 access points. So you have to think of power. You have to think of your rack space. All of that adds cost. And if cost were not to be a constraint, if you guys, none of you guys actually pay us big bucks. It's all small bucks. But if you were to pay big bucks, time is not your friend, right? Because your business partners want you on the transformation projects to deliver results overnight without taking any downtime. Any remediation you have to do to fix a bug, get a feature, today you have to go through a downtime process, and they want to come and minimize it. People need results right away. And if time is not a constraint, resource definitely is, because most of the places, your number of people in your teams are not growing exponentially, but the number of devices that are entering your network have quadrupled and exponentially growing over time, right? This is why you need a self-driving network, so that it first of all provides you with visibility, provides you with recommendations, and then, wherever possible, remediates problems when they occur. If you have been to the morning keynote speech by Sujay, you would have seen real examples of a camera being stuck on a switch port, and for days you would run without visibility, without getting visibility from or feeds from a loss prevention system, right? And that is basically what we are all about. At Juniper Mist, now part of HPE Networking, we have a rich full stack on the left for distributed enterprise, campus, and branch. This is basically meant as AI for networks, where AI operations will provide you with all of the telemetry, visibility, and self-driving actions that you should demand of your vendor. And on the right, obviously, is the complementary portfolio, networks built for AI workloads in data centers or data center interconnect or in core routing. So double-clicking into just the wired piece, the way we view the world at Mist is you have speeds and feeds in your underlying layer, right? And speeds and feeds are important because you have to think about whether you need 802.3 AT or 802.3 BT when you are doing a Wi-Fi 7 upgrade and a refresh. But speeds and feeds outcome is one small part of it. What we really want to layer on top is basically three fundamental things. One of them is cloud native. And what cloud native means is give you massive scale with lots of agility. Our largest deployment, a Juniper Mist deployment, scales to about, today is at one customer who happens to be a Fortune 10 retailer based out of North America, is 400,000 access points and 95,000 switches. When they used to deploy their previous vendor, they used to deploy about 20 sites a week. We have taken that velocity with our cloud-native capabilities that Sujit will demonstrate to you at about 120 stores a week, right? There are thousands of devices that just show up as light bulbs on our cloud every night, right? So that is cloud native. The AI native part is where AI ops comes in and gives you the telemetry and the visibility with which you can operate your network day 2 and beyond. And all of this is with the purpose that you are going to assure experiences for your end users, whether they are wireless users, whether they are wired users, whether they are managed, or whether they are unmanaged, unattended IoT devices. Okay? In a nutshell, our portfolio at Juniper Mist is very easy to understand. All of the purple-colored platforms that you see on the left, they are all access PoE platforms, starting with the EX4000, which was co-designed by someone in the room who now happens to be one of our customers. For data privacy reasons, I will not name any names. But really, the feedback was, hey, make switches simple. And the EX4000 that we launched earlier in 2025 is basically a platform meant for fast switching, fast turn up, right? That doesn't take ages to plan and deploy. It is a fixed form factor switch that boots up in less than 2 minutes. And why is the boot up time very important? The boot up time becomes important because that means you take less downtime for your upgrades. The boot up time is important because when you have a power outage and when you have to recover from a power outage, you want instant on for your devices to get connected back, right? And we have started that journey with the EX4000. The mid-range platform is the EX4100. That is where you'll start seeing modularity, modular PSUs. And then there are ruggedized versions of it that you can deploy in temperature uncontrolled type of warehousing environments. And at the top end of the access range is the EX4400. It has 3,500 watts of power for PoE. It will provide you with multi-gig capabilities. So if you're thinking of a campus network deployed with Wi-Fi 6E or Wi-Fi 7 access points, that is a good platform of choice. And then you have our distribution and core. And whether you are using the QFX series or the EX series, Mist can abstract all of that into simple provisioning, configuration, operations template that Sujit is going to give you a preview of. And obviously, there's a core network. Now, the beauty of this thing is that we support multiple architectures, whether you use simple L2 with EVPN VXLAN in core distribution, or you do L3 routing and do IP-CLO, take EVPN VXLAN all the way to the edge. Everything gets abstracted in an easy to consume, easy to provision, easy to configure and operate on the Mist dashboard. Without much ado, I'll hand it over to Sujit to take us through the journey.
All right, thanks, Sanjay. Okay, so now that we know about the platforms, let's talk about little architecture and how you can deploy this. From day one, when we added wired assurance, after I joined Juniper in 2019, I took the EX switches and was part of that journey. I started with that. So I divided this into day 0, day 1, and day 2. I think that resonates very well with all of our customers because you do that every day. When I talk about day 0, it's all about design. This is where you have received the boxes, but you have not opened it up. It's not online, nothing is, it's all in your warehouse. But day 0 is actually where you're designing the network. This is where you want to decide, are you going to do EVPN or no EVPN? This is where you're going to say that these switches are going to be my access switches, these switches are going to be my core and distribution, and you decide that first 10 ports of my switch is going to be dedicated for APs, the rest for my cameras, to just define a cookie cutter configuration. So that's what I mean by day 0 configuration, and that's where we come into and talk about templates. And I'll use this word many times during my presentation. Day 1 is all about opening that boxes, powering it on, giving it a cloud connection, and making it join the cloud and onboard that device into the cloud. And day 2 is all where I'm going to spend most of my time, is once you have the network deployed, how can you monitor it and look into some of the proactive actions as part of that self-driving journey, which we started a couple of months back. Okay? That's how my presentation is all going to be about in the 3 parts. So day 0, whenever I look into architectures, I've divided the campus architectures into 2 parts, always. One is called the distributed enterprise architectures, where we are talking about less than 500 AP type of an architecture, anywhere from 1 AP to 500 AP networks in your campus or distributed offices. But the biggest challenge with that is they are distributed, meaning they are all over the place, all over the country, or all over the cities. You need to manage those from a central location and have a standard-based configuration. And that was the goal of wired assurance, to give you a standards-based configuration so that you know this particular site, if there is a EX4000, first 5 ports are dedicated for APs. If you mix it up, you know how to troubleshoot that very easily. So that was the goal when we started working on this. So when I talk about distributed enterprise, as I said, it starts with a simple branch where you are having one switch, a couple of APs, and a router, SRX router, for example. But this is very important. Whenever you are looking at deploying any of the Juniper Mist networks, the platforms which Sanjay talked about, these are the platforms we are recommending moving forward. It doesn't mean that you have older switches like the 2300, 3400s, they're going away. But moving forward, if you are deploying newer networks, these are the switches I'm recommending for your access layer, and then for your collapsed core, simple deployment. And this blue box means virtual chassis, or if you're used to stacking, it's exactly the same in the Juniper Mist world, we call it stacking, okay? This is an important concept if you have already not deployed Juniper Mist or wired assurance, is templates. When I started on this back in 2021, we want to make sure that the configuration that is available on Juniper Mist is available in one place only. So I started with this concept of a global template. A global template is a template which will be applied to every switches in your network. There are certain configurations which is common everywhere. You might have a 1 or 2 NTP servers. You might have 2 DNS servers in your network, and you want that configuration to go to every switch and AP in your network, right? Then, at the same time, what I did is we can take this global configuration of your radius, NTP, and information, and then we apply that same template to a site. You might have a site on the East Coast, you might have a site on the West Coast. So what I have given you the option is you create one global template for your full organization, which has all the configurations which you need, which are common to every switches in the network. Then you apply that template to a site or multiple sites. So in this example, what I have is your global radius server is 192.168.10.12, 1.10, for example, 1812 port. But a particular site, if you want to replace that radius server because you have a different radius server for your East Coast or West Coast or anywhere in the nation, then you can override that template, the global template, at a site level, and then you override that at a switch setting. So even if at the West Coast office, you're building up a new radius server and you want to test it on one particular switch, you can replace that configuration for that particular switch. So the idea is you should not be creating more than one global template. I don't want to see that anywhere. You create one global template, then you apply that template to multiple sites, and then if you have to replace some configuration at a site level or a switch level, you can do that. So you get global template, site template, and then you have switch level configurations to replace that. And I'll show you an example of it right away, how this is done. But this is one of the most important concepts if you are looking at wired assurance with Juniper Mist, how we design the template, one single template, but giving you override options to do that. So this is how the template looks like. This is just for your reference, but I've captured a small video to show all of this. Along with this, we started working on a project along with it, which we call dynamic port profiling or color or colorless ports, where using LLDP, if your devices are supporting LLDP, which is connecting to it, we can push port profiles to the ports. So if you detect a missed AP or a particular brand of camera via LLDP or simply by a MAC address also, we can say that this is an AP. I'm going to convert that port to the right VLAN and apply the right profiles. If you want to enable 802.1x on that port, you can do that. And the beauty of this solution is when you plug that AP out of that port, it'll go back to its original configuration, which could be a VLAN, which is not going to let that AP go anywhere in the network, like a default VLAN or something like that. So that's what we call as the dynamic port profile. It uses LLDP most of the time if your devices are supporting it. But if your devices, if you have a camera which doesn't support LLDP, but at least you know the first 6 octets of your MAC address, you will be able to use that to create that port profile and say that anytime I detect this device on any port, I'll convert that port to the right VLAN, and when you take that port out or the device out, it will convert it to a default VLAN. So here's the example of how a port profile works, okay? So in this case, you go under the organization, and you go under switch templates. I've created a distributed enterprise template. Here you can see I've done all the configurations for the radius server, which is going to get pushed to every switch in the network. I've given the address for the DNS servers, etc. And then root password if you want to configure it. But here's the important part. This is where you configured your VLANs, layer 2 or layer 3 VLANs as needed. But this is an important concept we have in Juniper Mist is port profiles. Every VLAN has to be applied to a port profile. So in this case, I've created a port profile for .1x. And I've said that this is a trunk port, also, and allowed multiple VLANs on it. And similarly, I created a port profile. And this is what we are creating the dynamic port profile, where we say if I detect a Mist AP, it will be applied with an AP profile automatically. But this is an important part. If you have multiple switches in your network, we create what we call as roles in the network. We have created a role for MDF or IDF. Depending on the port profile or the switch type, we can say that if it's an EX4400 switch, which is going to act like an MDF switch, I'm going to use port 6 and 7 for uplink, and the rest of it is going to be for other port profiles on it. And this is what I'm talking about, making it standardized. And then you create that template and apply that template to all sites in your network. And then, if you have some certain switches at that site, it will automatically inherit all the configuration. Take a look at it. This switch has a role of access switch, but as soon as I change the role to IDF, it incorporates or inherits all the configuration from that template. But if you want to override anything, there's always an override button over there, and you can override that configuration at a switch level or at a site level. That's what I mean. It's a very quick look at what is, but this is the core of creating the templates where you have the global template, then you apply that to a site, and as soon as you apply it to that site, all the switches at that site inherits the configuration. And then, if you need to override that configuration at that particular site or that particular switch, you can do that. That's an important concept. So when you start playing with your wired assurance deployments, that is what you need to keep in mind, how we create templates. And I don't want to see more than one global template in your organization. So that's the first part. Then obviously we are talking about large campuses. Large campuses where we are talking about more than 500 APs, just to give you a number on it, where a lot of customers, they got used to EVPN VXLAN on their data centers. Now they're looking into deploying EVPN VXLAN in their campuses. So when I came over to Juniper in 2019, and I was in Cisco, I did my CCIE way back in 2001, and I'm an iOS guy and all of that. And I had to start learning everything on Junos after that. And I was like, okay, I need to do this EVPN configuration. It's like 200 lines of configuration, which I have to kind of learn from the beginning. That motivated me to say that, how can I do this very quickly in Juniper Mist Cloud, okay? So when I talk about campus architectures, this is one of my important slides, is what are the different types of architectures we support on Juniper Mist Cloud? We start with a very simple one, EVPN multi-homing or collapsed core, where you have deployed your EVPN VXLAN, which is this green box over here, in your core of the network. And the access layer remains as layer 2 switches. Simple, it could be a standalone switch, or it could be a virtual chassis or stacking switches. So you can see that it clearly says L2 below and L3 and above. So this green box is your EVPN VXLAN. Then you can extend it to a larger campus, university campuses, large healthcare, or where you have a 3-layered network. You have your core switches, you have your distribution, and then you are extending that EVPN VXLAN across but your layer 2 is still a simple layer 2 network. Your access layer is still on layer 2. And then you have the other beast, which is Campus Fabric IP Claw, where you are extending your EVPN VXLAN all the way to your access layer. The advantage with that is you get micro and macro segmentation. So if you are looking at doing segmentation, this is the architecture which we recommend, which is the last one, which is IP Claw Fabric, Campus Fabric, and also along with that, you get to use GBP or standards-based, group-based policies, along with any radius server. It could be a NAC assurance, or it could be any IETF's standard radius server. So these are the 3 architectures which we support on Juniper Mist, and that's where I started writing what we call as NCEs, or network configuration examples, using CLI. Then I thought, we have to do a better job on all of this. How can I make this automatic? But keep in mind, these slides are very important in terms of what platforms which we recommend for each of these architectures and each layer of the architecture. For example, the last one is important. When you are extending that EVPN VXLAN all the way to your access layer, you need to look into these 2 platforms. The EX4000 platforms, which Sanjay talked about, that is optimized for your fixed deployments. It does not support, for example, EVPN VXLAN. So don't do that mistake that you select to do IP Claw, but you have bought EX4000. You don't want to go down there. So keep this slide handy to know which platforms we are recommending for which architectures and which position. This is the conversation you don't want to have after buying all of these devices, okay? So that's when I started saying that how can I make this EVPN deployment also very simple? So I started doing this in 4 steps. First step is obviously deciding what type of topology you're going to deploy, EVPN multi-homing, or Campus Fabric, or IP Claw. Those are the 3 architectures which I showed you. You decide on that. Second, you define your networks. That means this is where you're defining your VLANs, VLAN 10, 20, 30, your IoT VLAN, your guest VLAN, and your employee VLAN, and map them to multiple VRFs on it. Third is you're doing your physical connections. That means the 2 core switches, how they are connected, what ports they are connected to, and how they are connected to your access switches, and how you're going to configure your ESI lag for those connections. And final step is push that configuration to the boxes. This is where it generates about 100+ lines of Juno's commands and pushes it down to the boxes over there, and you can take a look at it, what has been pushed to those boxes. So this is a 4-step simple process which I've tried to generate from day 1 so that you can push your EVPN configurations within 5 to 10 minutes. That was my goal. So let me show you a quick example of how you do this in less than 2-3 minutes over here. Once you have onboarded the switches in your network, once they are already in the network, they're not up and running, you just added them to the network. You can go to this menu, you select EVPN multi-homing, give it a name for that configuration which you are doing. EasyLag is the other name for it. You select the switches, which is going to be part of your core, which is going to be part of your access layer switches. You define the VLANs, which are going to be part of your EVPN infrastructure. You then define the ESI lag and the uplinks, which you are going to go to your network. What are the trunk ports? And then you do the physical connections, which I talked about. This is the connections between the 2 switches, between the 2 core switches, and then to your access switches. This is I think, the part which takes maximum time, but it's just once you have to do it for a couple of minutes, you need to know exactly which switches ports are connected to which port. And via LLDP, we will discover and show you if there's a problem with that. You might have selected wrong port. So this is where you're doing all your physical layer of connectivities. And once you're done, you apply the configuration. That's it. That's how quick it's going to deploy your EVPN configuration in 4 steps and push it down to the switch. Now, once you onboard the switches into the network, once these switches come online, it will automatically download all those configurations to your switches. So this is day 0. Your boxes are not up and running. You just configured the templates, and you applied the templates to your distributed enterprises or your campus fabric deployment. Now let's talk about day 1. Day 1 is all about how to onboard the switches onto the network. So every switch which is being manufactured in the last 3 years has a QR code built on it. You can take out your phone and you can scan that with QR code, or any way you can onboard those switches onto the network. As soon as you use your QR code and the app, the Mist app, you will be able to assign that particular switch to a particular site. Or if you have bought 100 switches, you don't have to individually onboard those switches. We will give you a single claim code, which you can add onto Juniper Mist Cloud, which will onboard all 100 switches into the cloud at the same time, and you can assign them to multiple sites afterwards. So you have both the options. What I'll show you is a quick demo of where this is the Mist app, which is available on Android and iOS devices, where you can log in and say that I want to onboard a couple of switches in my organization, which is sg.org. So all you have to do is go to device inventory, scan that QR code, which is in front of the switch, and then you say that, OK, it's going to be part of that. That's going to be the name of the switch, and that's all. And as soon as you do that, the switch will show up over here. You change the name of the switch, and you apply the right template on it, and it inherits all the configuration which you have done as day 0. So you have configured all the templates. Everything is ready to go. Now, you scan the switch, switch it on, make sure that it has an IP address to go out to the internet, and it will test out if it has connectivity or not for outbound. Initially, we were using an outbound of TCP 2200, but now we have moved on, and as long as those switches have an HTTPS connection outbound, it can reach the Juniper Mist cloud and onboard itself. It knows exactly which organization it needs to go to, as well as which site. That's up to you to decide which site will take which switches onto it. So that's day 1. You onboard the switches, and you bring them onto the right site. And now everything is up and running. Let's see what you can do for day 2. What are the enhancements we have added as part of day 2? So usually, the day in the life of a network engineer, I was a network engineer, I was a TAC engineer, it's stability of the network and continuous monitoring of the network is what you do every day. And you want to make sure that you can schedule a time to upgrade the networks, maybe just once in a year, maybe 2 hours once in a year, you get to upgrade the network. But that's where we are going towards. You must have seen this slide 5 times today in various presentations already. But I want to see what I am doing as part of that self-driving network on wired assurance. I want to update you on that. So it all starts with 2 ways I'm looking into it. Once it day-to-day, how can I gain visibility into the client and the user's experience or the network or the device's experience? And then what are we doing for proactively monitoring the network? Those are the 2 areas I'm going to talk about for the next few minutes. So measuring the user experience, that's where we are talking about what we call SLEs, or service level experience. In this case, we are trying to solve these problems. Is that switch having a cloud connectivity issue? Is there an MTU mismatch? Is there a DHCP server problem or an authentication problem? And all of that is part of what we call as SLEs, service level expectations, where we started obviously with wireless. We're talking about wired. We're looking into it and saying that how is the throughput on the network, how long it is taking for users to connect to the network, how is my switch health, and how is my switch bandwidth. I call this sometimes a coffee view. That means you come in the morning, 9 o'clock, you log in and see how is my wired network doing for the whole organization or certain sites. We can clearly show you that if you are having 100 sites, there's an org level view, which a lot of our customers use every day to see that across all my sites, you're maintaining hundreds of sites, how is my switches behaving over there? And if there is anything red for, say, switch health or successful connect, because somehow you have fat-fingered and entered the wrong DHCP server on a particular site. It has happened. Many times customers have brought up a new site, they tried to modify the switch template at that site and fat-fingered a radius server information, or they have fat-fingered a configuration for the radius key. That has happened to a customer site. How will you know that? That's where you come to the SLEs and you look into it and look at the full org, or look at your particular site to see what's going on. I'll show you a quick demo of this. So here's how the SLEs look like for wireless. That's where we started. Let's talk about wired. In this network, we are looking at throughput, successful connect, and switch health on it. And all of this have sub-classifiers in it. This is where we look into how is your DHCP server doing, how your radius server is doing, as well as if there is something wrong, where is the problem, and which all users are getting affected. So the idea is within 3 clicks, you need to get to the bottom of the problem. So this is something I recommend all customers to look at it at least once in a day when you come in. If everything is green, everything is above 80%, go on with the rest of your day. But if anything is red or orange, that means you need to pay attention to it. And that's the benefit of that AI ops we are talking about, which is getting derived from the Juniper Mist platform. So you can look into various things like switch bandwidth. That's a common problem we see if your network is oversubscribed or not. Is the congestion there on your upstream switches or upstream link between the access switch to your distribution switches? These are very hard problems if you think about it. You don't have these type of visibilities if you are not monitoring or creating your own servers. So that's what I'm focusing on, are these 4 SLEs. This is something what you look into it, you keep on updating it as part of it. Then comes the visibility part of it is how is your devices behaving on it. And this is where I introduced what we call as the view of a particular switch, where you can start looking into, obviously, the faceplate to see what devices are connected to it, what are the profiles that has been pushed, how many APs are connected, and also at the same time, total power drawn on it, how long it is up, normal stuff, and also what template is applied on this particular switch. Because you don't want to apply a wrong template on that switch, then it will inherit all the wrong configurations on it, right? That's where you look into it. And then obviously you look into the version compliance, if it is correct or not. And also, and a very important thing which we are constantly working on is switch events. This is one place where you can come in and see what is going on with that switch in terms of if there is any events going on, alarms related to fan, chassis, and all of that in one location itself. And also, as many users are connected on that switch, if you want to see how they are behaving, you have the client events available, or you want to search globally. If you look at this bottom screen, it's from our deployment in Sunnyvale office for Juniper over there, and you can see about 2,000 clients, all wired clients. If you want to monitor them and list them out, you'll be able to see it. So the idea is, if you have one client, you don't know where that client is, but they're calling in and saying that I have a problem, I cannot connect to it. You don't need to know where is he calling from, which switch he is in, and which site he is in. You just add the MAC address of that user if they can tell you, or the name if they're doing 802.1x authentication on that device, just do a global search, and it'll look across your organization, across multiple sites, and show it to you exactly where they are. This sounds simple, but trust me, this is what you struggle with every day when you get that phone call over there. That's something I'm focusing on, making sure that. So I'll show you a quick example of what I'm talking about. Here is another switch which I'm monitoring. But this is an important part. I added several utilities on it where you can go in and look into what's the switch configuration. You can do an SSH back to the switch also. I highly recommend not to make any switch configurations directly on the switch. Any configuration changes you want to do it from the cloud and push it down. Because if you make some changes on the switch configuration, next time we do a cloud push, we will override that configuration directly. So cloud is the source of truth. Keep that in mind. If you do need to make any show commands and look into what is going on, please go ahead and do those. But at the same time, don't. So this is where you look into all the events type which is there in the network. I have added many, many events over a period of time. And also at the same time, you can monitor a virtual chassis, this is a smaller virtual chassis with 2 switches only on it. It tells you which one is your primary switch, which one is your backup switch, and all the details is over here. The goal is you don't need to go and do a CLI until something is missing over here, really, over there. You should be able to monitor and see everything on your switch from here. Finally, we added, after a lot of requests from a lot of customers, is upgrade orchestration. This is very important, which we have been working for the last 6 months onto it, and it's available for everybody, is how can we upgrade one single switch or every switch in your network. So we can design this in such a way that every time your new switch comes into the network, you can define a golden software version, and it will get updated automatically. Or they are all operational. You want to apply or upgrade the switch on a Friday evening, how you can schedule that upgrade and do that upgrade at 9 in the evening when all your users are gone. And if there is a problem, how you can revert back at the same time. And so that's a quick look into the upgrade orchestration which we have done. You can do an enable auto upgrade. It lets you select which software version. When you look at a suggested software version, it's the same as what TAC is recommending. So I work with TAC every week to make this updated so that we show you the TAC recommended version, and you can select which platform you want to use, which software versions, depending on whatever your TAC is recommending or your AS engineer is recommending. At the same time, you can go in and individually upgrade the switches, where you can do a scheduling of the upgrade process. You can say that this particular site, I want to upgrade this particular set of switches, for example. So you don't want to upgrade the full site. So we give this granularity saying that, OK, we just want to target one site, one platform at a time only, so that I don't want to take down the whole network. So I give you all these options over here to say that, OK, this particular switch, or even this particular model, but if the role of that switch is IDF, I'll out that, and you can upgrade it immediately, or as I said, you can schedule it at 9 in the evening, and all of those options are available. Okay? This is a new capability which we added, and I think this is very useful for all of you, is going to be packet captures, especially when you are deploying the switches thousands of kilometers away and you are not having an admin at that site, how you can enable this packet captures. There are 2 types of packet captures added. One of them, what we call as the dynamic PCAP. That means if there are certain events continuously happening in your network, ports are going up and down, continuous failure of 802.1x authentication on the ports, we will do a packet capture automatically and save it in the cloud. The other option which I have added over here is on-demand packet capture. This is where you can say that this particular port, I want to enable packet capture on it, and then get those packet captures come in to the cloud so that you can download them in your Wireshark. You don't have to deploy somebody with a laptop at that particular site. And the final topic, which is Marvis AI, the self-driving part of it, I'll quickly touch on it. This is an example from a customer who has deployed about 4 million switchboards, and where we could come in and look into only 17 ports which are not passing traffic. This is where we are looking into how we can look into the needle in the haystack problem, what you have. So currently, we have added 2 self-driving actions for port stuck and misconfiguration. This is where we are going to keep on adding more self-driving functions into it. And last slide on my presentation is, before ChatGPT came into effect, the virtual network assistant, which is going in and looking into, and you can do queries. I want to do a troubleshooting of this device. This device has not been able to come online. What's going on? You start your troubleshooting from what we call as the Marvis Virtual Network Assistant. So that's all I have time for today. I'm going to be back in the show floor. If you have any questions after this, please do stop by. I can answer some additional questions, or when I'm outside, I can ask. Thank you for attending.